All right, man. Going Native 4.
GoingNative 4. You know,
you want to do this or you want to do that?
Both things. You know, I can't believe we could have lasted so long.
I know. You know what? It's impressive, the amount of traffic, but more importantly, the conversation we're having. In the last episode of Going Native, Going Native 3, we're at 213 comments now.
I'm still reading.
Still reading. And hey, you know, I'd like to shout out to C64, PYFB, KMKY, Dennis, Glenn, Thomas, Warren. Thanks for challenging us.
Absolutely.
And asking some interesting questions and good questions. And to Jim and Herb for coming on and giving some extreme wisdom.
We're here and we call them, you know, so.
Rock and roll, man. So never be afraid to speak your mind. Now that thread was all about C++ CX, which this episode's not going to be about. This episode's going to be about the elephant in the room.
Sure.
Which is COM, but actually not specifically COM. We're going to talk about ATL and WTL.
Sure.
And Jim Springfield, of course, is the creator of ATL and had a hand in WTL. That was actually something written internally by a guy whose his first name is Nanid, last name Stefanovic, I believe, or something like that. Forgive me if I got your name wrong. You know who I'm talking about. Which is just a wrapper on top of Win32.
Sure.
And so ATL makes it easy for us to write COM objects at the simplest definition. And so we're going to talk about that, understand the model, the rationale. WTL, the Windows template library, is built on top of ATL. And we're going to dig in with Jim, man.
Absolutely.
So what's you got news?
Yes, I mean, there are a lot of things happening, of course, you know, in the C++ orbit, both at Microsoft and outside Microsoft, and we are, you know, at all time checking what is happening out there. I guess you guys are already subscribed to the Visual C++ Weekly. This is like a newsletter we are sending every Saturday morning, and it's trying to compile, you know, the most, how can I say it, the most important news that have happened by the community itself.
Yes.
Of course, we are including also the kind of things we are doing, like this program, the blog, etc. But also things, you know, like, for instance, Bartosz Milewski is now doing a tutorial on concurrency, that is C++ concurrency, nothing, you know, like C++ AMP or concert, etc. It's just what the standard provides to you, that is a lower level, but at the same time, you know, it's like the portable way to do concurrency.
Excellent.
So we are in general compiling all those news and all those things that are happening out there. You may also find that if you are checking not just the Visual C++ blog, but a sister blog called Parallel Concurrency Native Code.
Yes.
There are recently, you know, like a spike in the kind of samples you can do with C++ AMP, in, you know, also PPL for Metro style apps, etc. So I wanted to highlight that you can check as well. And we are going to talk about conferences that are happening. You know, we are later going to blog in the VC blog about the conferences you can either attend or participate, you know, with deadlines for the submission process, etc. I mean, I'm not talking about Microsoft conferences, just, you know, but also BootCon or those conferences that are out there.
Absolutely.
So good to take into account.
Absolutely, man. And so also about the PPL Metro stuff, there's an interview on Channel 9 I did with
Rahul,
Jen and
yes,
Rahul.
and Genevieve.
Jen's someone that no one's met yet, but she's a hardcore dev, C++ dev, doing a lot of great work.
We should invite her, you know.
Yeah, absolutely. Yeah. But I mean, for now, just go and watch that video.
Sure.
Download it, play with it, give them feedback. Of course, that's a C++ CX thing as well.
Sure.
So, you know,
I mean,
calm down, PFYB.
Absolutely. It's like how we wrapped in the case of Metro style apps in order to take advantage and leverage the PPL, which is not part of the WinRT, you know, framework.
Exactly.
So it's a way to take advantage of that. You can use that if you are doing Metro style apps. You can use that with the C++ CX syntax. If you are doing just your traditional desktop apps, you can use Concert and the PPL as it is, you know, as it comes, with no
and
extensions.
that's actually a really good point. I mean, let's just, you know, we thought we made this clear in our actually Going Native 2 when we had Tarek. Then we had Going Native 3 where we had spent really good quality time with Marian.
Yes.
So, you know, I'd like to end it here in terms of this conversation, at least for this, what we're doing with Going Native, going forward for a while. We can always come back to it. But if you want to write a Windows 8 Metro style application you're going to want to use C++ CX or use WRL. It's up to you. I recommend C++ CX.
Sure.
You may not like it. You recommend it. I'm sorry that I belittled hats and refs, man. And Glenn kind of gave me a hard time for saying it was a small extension. Any extension, I guess, isn't small. So let's agree to agree.
It's an ongoing job. Even the community itself, and some people are already doing that. You can eventually. I have heard interesting proposals on why not to wrap up this into a sort of ISO, extensions. The community itself could eventually, try to start that as an open source project, and we can keep focus everyone, on the area we are already doing. We cannot do everything.
Of course not, man. You guys are working hard. You guys are working hard. That's good stuff. So we're going to go talk to Jim Springfield, as we just mentioned, because ATL is one of these technologies that's been around for a while, and actually was created to solve the problem of writing COM components on Windows, although it is platform independent. So, come and join us. And I have some of your questions, and we're going to geek out with Jim, the creator of ATL. We're going to throw in some WTL too, man.
Okay.
So we'll be back. All right. So we are finally, after many years, with Jim Springfield, the creator of ATL and many other things. Thanks for coming on Channel 9.
Thanks for letting me be on here.
Of course, man. So let's just start at the beginning. Number one, what is ATL and why did you create it? Give us some historical perspective.
It's the active template library. Active doesn't really mean anything anymore, but back in the day when we developed it, ActiveX controls, everything was active this, active that. So when we developed it, we ended up with that name. Okay. Interestingly, it had a completely different name at the time, which was more related to why we developed it in the first place. We had a group called Visual C++ Enterprise Edition. We only ever shipped one version. But there was this completely separate team, and part of it was to do business logic and middle tier, and the plan was that would be all COM based. Okay. And the thing was, there wasn't a great technology for doing COM in those days. MFC had some support, but you had to buy into the whole framework, and it really wasn't optimized for COM. So that's kind of the basis of it. We ended up never shipping kind of that business logic part of it, but the COM part, ATL, ended up being successful.
Excellent. Now, what is it about COM that requires the advent or development of some higher level abstractions to simplify how developers express in it? I mean, what's the interplay here?
Well, C++ often is object-oriented and COM is object-oriented, but COM goes kind of beyond that, and also being remotable, doing process independence, cross-machine, and so there's a lot more information you have to carry in order to marshal all those types. It also uses reference counting, which while you can do that in C++, it's not a native concept in C++. Okay. So there's several kind of high-level things that we did in ATL to make that easier and adapt it to C++.
Sure. So, I mean, COM is a foreign object model
to
C++'s object model. And it certainly seems that ATL is widely used, both in Windows and Office, and I can imagine any other place that has some UI on Windows and Chrome and IE. Yes. I mean, it goes on and on and on.
Right.
Now, in some sense, what's wrong with MFC specifically? I think you already answered this question, but there's some people out there in the audience who wanted to know sort of the reasoning behind not just making MFC slimmer as opposed to creating something new.
Right. Well, that's always a challenge when you have an existing library, that there's only so many ways you can modify it without breaking the existing users. And one of the things MFC did is it actually went back to 16-bit days when our compiler, our C++ compiler, didn't have multiple inheritance. And so it would implement COM using embedded classes rather than multiple inheritance and inheriting from multiple interfaces. So there were some design decisions that MFC made about COM that simply we wanted to overcome.
Sure. I mean, that makes sense. Now with COM, you can create single-threaded objects, apartment model objects, etc., etc. It's all about programming COM objects, right?
For the most part, yeah.
For the most part. And it lets you do it easily. So, and again, you went back, you already talked about active being just a marketing term. Let's talk a little bit about what is it about the underlying COM structure. For the people out in the audience, we talk about COM a lot, right? We say the word a lot, we throw it out there. I mean, COM is actually, seems to be not the most complex thing in the world if you just look at what it affords, right? Interface-based object orientation, et cetera, et cetera. Communication between objects and components. Talk to us just a little bit about, you know, why that's complicated.
Right. There's several reasons. The activation model is very different. It goes through the registry. It's about finding things registered on the machine. So there's that aspect. There's the remoting part where you have to have proxy stub code available to marshal the interfaces across apartments and processes. And then the fact that you have apartments at all is kind of unusual from people used to programming within a process, right? They may have to deal with concurrency with critical sections and locks, but in COM you kind of get this automatic marshaling of calls to different threads. So that's just kind of different. Sure.
Now, let's diving down a little bit into the ATL COM object model. 3 ways to create a COM object, right? So the standard option is CCOM object. Then you have CCOM poly object and CCOM ag object.
Right.
Can you talk a little bit about those?
Sure. So back when we were doing ATL, one of the things I really wanted was for there not to be any reason not to use ATL, right? And part of that was it should implement COM objects as efficiently as possible, right? If there was an excuse that somebody could say, oh, well, I can do this a little better by doing this myself, right? Then it just means adoption of ATL would be even less. In hindsight, you may argue that we kind of overdid that. But that's reflected in kind of the question you just brought up, which is a CCOM object can't be aggregated. A CCOM ag object can be, and a CCOM poly object will actually, depending upon whether you're asked to be aggregated or not, will actually create a different C++ class using templates that derive from the class you actually authored. So it's very kind of messy, but at the end of the day, it lets you be as optimal as you want to be, right? So you can say, I'm never going to do aggregation, I'm just going to do it this way. I want per instance objects to be as efficient as they can, or I want to support aggregation, but I want my code size to be really small, so I only want to have one way, but there'll be a little bit of extra overhead in each instance.
Interesting. Now, just to kind of, again, you know, I think a lot of times we always talk about solutions and answers and don't refine and sort of, how shall I say, you know, what's the question that ATL answers? How's that for a question for you?
Right. One of the things we always thought was getting a basic COM object wasn't hard, right? You inherit from IUnknown, you implement addref release query interface, implement your methods that you want to do, and a few other little things, and you kind of have things running. What we really wanted ATL to do was to make it really easy to do COM correctly. And that's where it gets tricky, right? To do aggregation correctly, to do marshaling correctly, to deal with your module reference counts and do unloading of your DLLs and your exes. Those were the types of things that people would struggle with and tend to mess up. Doing, like I said, a simple COM object, all it has to do is IUnknown. There's not a lot of work involved.
Okay. And again, this was designed to make writing windowed applications on Windows, as you said, easier, but also easier to control and understand, as you just described. So ATL, whereas COM is platform independent in some sense, Fair enough?
Right.
ATL is specifically designed around Win32 and the Windows programming model for developing UI. Now on top of that, there's also this thing called WTL.
Right.
Can you tell us a little bit about that?
Sure. So back when we did support for true ActiveX controls, meaning ones that had a user interface for like embedding in Internet Explorer, that was the big reason for being back then. You could also embed them in your own apps, but they still underneath used HWinds and the Win32 and User32 APIs. And so in ATL, we wanted to support the UI-based ActiveX controls. And so we did some basic infrastructure to make that easier around thunks for WinProcs and basic creation of windows, consumption of windows, that type of thing. But it really didn't go beyond that. There was a group of us in VC at the time that felt that it would be interesting to do kind of a new version of MFC, for lack of a better term there. And WTL kind of grew out of that of, you know, how would we create a C++ Win32 library, you know, 10, 15 years after MFC had already been around and been existing. So kind of based on template techniques and that type of thing. And so that's really what WTL became, was a lightweight Win32 framework built using templates.
Okay.
So it never actually shipped in our product. We were getting a lot of use internally, and in fact, it's still used a lot internally. Visual Studio still used it internally. It's checked into the Windows source tree and is used by Windows. A lot of the native C++ projects around here still use it. So it's been a useful tool. We also decided to, you know, try to release it, get it out there for people to use, and it was, I believe, the first open source project that Microsoft ever actually supported.
Interesting.
Yes, and it's still available on SourceForge, and one of the guys that was the driving force behind it used to be on the ATL team, Nenad Stefanovic.
There, that's his name, okay.
Yes, so he still works with WTL and is active on SourceForge, and there's still bug fixes and all that type of thing. He left Microsoft a couple of years ago,
okay.
But he's been active in doing that. Google Chrome is using it for their UI, their Windows-specific code. So it's just good for kind of native code where you can't use MFC or you don't want to buy into that large of a framework. You can kind of pick and choose and use pieces of WTL, whether it's the windowing stuff, command routing, printing, print preview. It's got a somewhat broad assortment of things to do. I would actually recommend people check it out. It's actually pretty useful.
Totally.
To use. So, and it's available today. It works on, I don't know how far back. I know Dev 10, 2008, 2005, I think 2003, and maybe even VC6 if there's any of those people.
I think there are still some of those people out there. Right on. That's interesting. And I guess in some sense that's what's cool about ATL. It's lightweight, fast, small components that you can make, COM components, whereas MFC is sort of, you have to take the whole elephant with you wherever you go because of all the interconnections between the libraries and blah, blah, blah. So that's really one of the nice things about ATL is you really made a lean, mean UI programming platform on Windows. I think that's great stuff.
Right. One of the interesting things there is that kind of back when we were doing it, MFC was still around. A few products used it, but there was a aversion to taking a dependency on something that had a DLL that was 1 megabyte in size, which in today's terms seems just kind of crazy, but there you have it. I mean, for ActiveX controls where you're worried about download over, you know, a 56K modem, you know, small size was important. So yeah, there's some overlap there, but they're really kind of targeted at different uses.
Certainly, absolutely. I mean, it's not one or the other, but some would ask that. And WTL is certainly something we haven't talked enough about in the past, because I think that's super cool. So hopefully people will play with it and check it out.
Yes.
Now, I got a question for you from Ion, who's actually an old-time Niner, who's also a native dev. He now works at Microsoft, software tester. engineer
All right.
in the SQL team. He asked this question: why isn't there a CCOM prop variant? And so I asked him to, well, what do you mean? Well, to encapsulate initialization and cleaning out of prop variants, prop variant init and prop variant clear, basically. It would make organizing exception throwing code easier. What do you think about that?
That's a good question. There's a couple of variations of variant around that are slightly different, and there's no particular reason. Hey, if he sends us the code, maybe we'll put it in. So
you hear that, Ion? Right on, man. Very interesting. What was the hardest problem you had to solve? Hardest, like what kept you up at night when you were creating ATL?
One of the trickiest was actually the WinProc thunks, which the problem goes back to in Windows, when you call create window, you give it just a function pointer. And there's no context that you pass. There's no cookie, there's no this pointer, there's nothing like that. It's just a bare C function, which kind of was fine in kind of the original days, but what that meant is there was no way to use the same function for multiple instances of a window and recover that context. People would do things like do a set window, what was it? Set window property, where you could add extra data and then you'd have to pull it back out. The problem there is you had to own the Win class and register the Win class yourself. If you were subclassing an existing window, there really wasn't a great place to put it. MFC used a map of HWins to essentially object pointers. And that had a problem with, if you had multiple kind of DLLs within the same process, subclassing the same window, then that kind of fell over. So in ATL, we really wanted a different mechanism that was very fast. And so what we came up with was this idea of creating essentially a window procedure every time you created a window. So we would synthesize this little bit of code, the WinProc thunk, when you created a window, and actually pass the address of that to the system, and these would be allocated on the heap. So coming up with that technique and actually making it work was very challenging, and then we also had to make it work on all the other platforms that we supported, which at the time was, you know, we had MIPS and we had Alpha and then the Windows CE platform. So there were a lot of different platforms, and so it was kind of painful to do, but it's kind of was a nice technique that we developed there. So
all right, since we're talking about COM and COM objects and what ATL affords us up at a more abstract level, when you build a standard COM ATL COM object, there's essentially two objects you're dealing with, an inner one and an outer one. The consumers of your object access the functionality of the inner object through wrapper functions.
yes.
Can you talk about that design?
Sure. So it's really an inner class and an outer class. There's only one object that actually gets instantiated, but the class that the user authors never gets directly instantiated. Instead, it is derived from, and we talked about this a little earlier with CCOM object, CCOM ag object, CCOM poly object, and there's even a few other more esoteric variations of that, like CCOM stack object, which you should never need to use. But anyway, so those templates get used to derive from a class that the user writes, and then the derivations are what are actually instantiated. So that's kind of a very kind of weird thing for most C++ programmers, that they're used to like authoring a class that, oh, I'll do new on it. Whereas if you actually try to do a new on your ATL class, you'll get a bunch of compile errors about, you know, functions not being implemented and it being abstract.
Interesting.
And that's just how it's designed for efficiency.
For efficiency, but is it also designed that way to support the interface-based object orientation of the underlying model of COM?
It's really more about efficiency, because a lot of the like other libraries I've seen for COM you inherit from some base, it may implement parts of it, but they don't really have a need for you to further derive from it. We do that so that you can add additional data members or not, and make it as small as you can in cases where you don't need that extra data members, but like for when you need support aggregation, then you need an extra data member, and so that gets added on by the template class.
Okay, interesting. All at compile time.
All at compile time.
It's important for us to note.
Yes, aren't templates wonderful? Yes.
They are. Well, let's say I'm glad there's people like you that can spend the time doing the rocket science and brain salad surgery of putting these template libraries together. That's not an art that all C++ developers have really, what's the right word, honed, croned? I don't even know what the term is. You know what I mean.
Right. And to be honest, we learned a lot doing it. And there are some things that, you know, in hindsight, we probably would try to stay away from, and then we could probably do better.
Like what?
One is we actually added a compiler extension called if exists and if not exists. And it's used in a few places in the ATL source. And what it does is it lets you test for the existence of a symbol in a base class. It's useful when you have a template class that's going to derive from, say, user-authored class. And if exists allows us to say, hey, if this user defined this method in their base class, then we're going to add all this extra code. And at the time, we didn't really see a clean way to do it without this kind of kludgy language extension. Today, I would say there's using SFINE, which stands for substitution failure is not an error. It's a common way in template metaprogramming to accomplish these types of things, and you can detect that a class has a certain capability and then generate like use a different template specialization based on whether that type supports it or not. Now at the time, our compiler wouldn't have even if we had known about SFINE, our compiler at the time wouldn't have been able to do that. But that's the type of thing that we can clean up, and it's in fact one of the reasons I think with WRL and WinRT, with that template library, we were able to take advantage of some more modern techniques that either we didn't know about at all or that hadn't been defined in the compiler or our compiler didn't implement. And again, it's like one of those things like we were talking about with MFC, you can't just break compatibility and break customers. So we kind of decided to leave ATL as it was, and WRL really pursues kind of the even more modern approach.
Interesting. I mean, because I think that's one of the kind of important questions that I think when people learn about WinRT and the fact that it's, you know, basically implemented in COM, right? It's COM is very important and very native to WinRT. And people might wonder, you know, why not just modify ATL to take advantage of this world, because underlying that ABI and API surface is the elephant in the room, COM. COM is a beautiful thing, man. I think it's amazing that it's still, we can't ever get away from it, even though some have declared it was dead and are now saying that they're happy it's still alive. You know who you are.
Yeah, I agree. And in fact, I almost wore my "Calm is Love" shirt today for this, talking about ATL, which I don't know if anybody remembers that, but Don Box, who's here now, had a company called Develop Mentor, and he would do lots of teaching and training sessions, and he had these T-shirts with a heart on it, and inside it said "Calm is Love."
Yes.
Yeah, I still have mine. So
awesome. Yeah, and then Don's still loving COM these days. And Chris Sells also is here, and he was a big ATL fan, co-author of an excellent book on the subject.
Yes, and he's a program manager in Windows now and driving a lot of the WinRT API design. Been involved a lot with him on that kind of stuff. So yeah, it was actually interesting. Until then, I had never actually met Chris. So yeah, it's kind of neat.
Well, he knew a lot about your work.
Yeah, well, we definitely, I wrote the intro for their book, and so yeah, we definitely went back and forth a lot.
Awesome.
On that.
That's great. Now, just real quickly, you mentioned there's some, in WRL, there's more advanced template usage that you couldn't take advantage of back in the day because the compiler just wouldn't be able to support it. What are some examples of these advanced template capabilities?
We do use Sphinx in a couple of places, and more true meta programming techniques than ATL. I haven't been involved directly in WRL. I think Sridhar did a pretty good video on that.
He did.
So yeah,
and we talked to him about that. We talked to him about that, about sort of the more of the why it exists at all, and sort of what is WRL for.
Right.
And so that was sort of the focus. We didn't really dig into implementation details. At some point, it'd be fun to do that.
Right.
We talk about template meta programming a lot, but we don't really ever.
Right. It's definitely an interesting code base to look at. I've consulted on a few things, but my focus has been much more on the C++ CX.
Yes.
For this version.
Absolutely, which is again making it easier to definitely do reference counted COM programming for WinRT.
Yes.
And we've had a nice interview the last time we did this with Marian, where of course I arguably said it was a small extension, hats and refs, no big deal, man. So and of course it ruffled some feathers, but most of the feathers out there aren't ruffled. I think it's because it's very good stuff.
Yes, we're hearing a lot of good things from our MVPs and other customers. So,
Absolutely.
I mean, you're never going to make everybody happy with something you do, but
yeah,
nice.
I
think it's a good technology that'll help a lot of people.
Absolutely, and I think it's one of the things we lose track of is let's say I'm a C# developer, for example, and maybe I do want to experiment with going native, if you will, or not to overload what that term actually means, but I want to play around with writing code on Windows that's sort of only abstracted by the operating system, not some other virtual machine on top of that.
Right.
So, which is the case in JavaScript and C# and VB, for example. C++ CX sort of makes it a little more comfortable for me to go into that world than to go into the straight C++ and certainly the ATL kind of experience. So, right on to that. I mean, I think that's something we don't talk about very much. It's a nice bridge, I think.
Yes, and I was never a C++ CLI user really, or managed code. I'm always about performance, native to the metal.
Rock and roll.
And with CX, I mean, it gives you some of the benefits, right? The automatic management of objects and that type of thing. But at the end of the day, you can go look at the assembly code and see, oh yes, this is just a virtual call, or this is just a jump, and it's still to the metal and very efficient, which is what I like.
Anyway, I just wanted to say thank you for spending time on that Channel 9 thread, which is now known as the Epic thread. Somebody,
it is epic.
Yeah,
yes.
Somebody did that on Reddit. They said, check out this epic thread on C++ CX.
Yeah, it was fun. I had fun reading and commenting on it. So.
Right on. Well, thank you for doing that.
Sure.
And thanks to everybody else out there for, speaking your mind and engaging in a very civilized way.
Yes, it was good.
And hopefully they've learned, because I think what you said was very clear, very well articulated. Same for Herb. But we're going to move beyond that and move on.
Yep.
So COM is very interesting. COM is love. It's not dead.
That's right.
It powers Windows 8, WinRT, and that's as far as we'll go with the Windows 8 stuff. Now, I do want to get you on the whiteboard because you're a software engineer.
Yes.
And people like to see that. And one person in particular asked specifically, maybe he could get on the whiteboard and sort of draw some pictures of ATL and sort of the flow of, say, I don't know, building your first ATL class that, app that pops up a window or something simple. But I'm more interested in sort of the structure of ATL, and if we could just draw that on the board.
Right.
And let's see what that looks like.
All right.
All right. So what does a ATL COM object look like?
All right. As we mentioned before, it is kind of unique. So if we'll draw boxes, because we always have to draw boxes, right? So we'll call it my class, right? So you would have written class my class, right? That's C++. Then you would have specified, okay, what are my base classes? And in ATL, there's several base classes that you would typically use. One is what we call CCOM object root. And that provides a lot of the basic IN known infrastructure for you, but without actually implementing any of the IN known functions. The other pieces are your interfaces. So if you've defined your own interface, then you would just say inherit from it. So let's say you've defined an interface called IFOO, right? You would just inherit from it here because ATL doesn't know anything about that class and it can't really do much for you other than implement IUnknown, which will happen later. Now, if you're implementing, say, an existing interface that COM is defined, like iDispatch, for instance, you would use iDispatch impl, and then you'd give it like your actual class. So in COM, if you have a interface like iBar, I've used IFOO, so I'll go to iBar. iBar, say, derives from iDispatch. So in middle, you'd have said it inherits from iDispatch. So iDispatch has a lot of methods that need to be implemented, like get IDs of names, invoke, and several other things. It's a bunch of housekeeping. And so you can use this helper class to implement that part of it, and then that actually inherits from your iBar. Okay? So that's an example of still you're defining your own class, but there's parts of it that ATL will provide implementation for. Now there's a whole nother set of interfaces that would be used if you were actually going to create an ActiveX control. There's anywhere, I think, from about 6 to 15 interfaces, depending upon all the features of an ActiveX control you're going to do. Like IOLA in place object, I can't even remember them anymore.
Sure,
but
that's fine.
There's a massive number.
Okay.
And so you would inherit from some core set of interfaces that you would always have to have, and then some optional set like, oh, windowless controls, that's another one. So where you wouldn't have to create an HWin, instead you scribble directly on your containers DC. So there's lots of different things, and so ATL is about providing implementations of interfaces. That's one of the core things it does. IUnknown is one of them, and that's the primary one. iDispatch is also very heavily used. And then for ActiveX controls and OLA, there's a whole bunch of other interfaces.
Okay.
In fact, the first couple of versions of ATL didn't support ActiveX controls, and so we didn't do all of this part initially. It was really just about IUnknown and iDispatch.
Okay.
So then within your class, you will add several things. If you're an ActiveX control, you're going to need a message map. So you have your begin message map and all of your message handlers in there.
And that's a macro, right?
Yes, it is a macro. It is implemented differently from MFC, but yes,
Okay.
it's still a map. There's things like an event map, other types of maps that are there, but there's also things like registration information that you can put in there to control how your thing is registered. There's stuff about activation, and again, these are all controlled through various macros that you drop within your class, as well as implementing all of your IFOO methods and your iBar methods.
Yep.
Okay, so now you would think, oh, you know, I've got my class defined, I inherited from my bases, all I have to do is new it up. Well, that doesn't quite work. And we kind of touched on this earlier because we wanted to be able to provide something that can be kind of optimally efficient in multiple cases, like in the face of aggregation or no aggregation. So what normally happens is most people will simply use CCOM object of, I need to write my boxes bigger. CCOM object of my class. You also rarely would type this because the class factory will automatically create that for you. And that's controlled again by some of these macros in here as far as how you're allowed to activate. I'm going to erase this for real quick because I need more room. So CCOM ag object is one. CCOM ag object. I'll do that one. There's also, or sorry, CCOM object. CCOM poly object, right? You can also do it. And then there's even one called that's C stack object, which is kind of weird for a COM object. But again, it was like, hey, there is a particular case where somebody needs to put a COM object on the stack. They're going to hand out interfaces. They know it's never going to live past the lifetime. And so then when all those functions return and we return the object's on the stack so we can free it immediately without having to do an allocation. So it's a very rare thing that somebody would actually use, but again, it kind of fit into our whole model of we're not going to leave one drop of performance on the table. If somebody would ever want to do it, we're going to provide a way to do it and not give them an excuse not to use ATL.
Excellent, man.
So.
Well, that worked because a lot of people are using ATL, as we've already talked about.
Yes.
Now,
yes.
I want to ask sort of a question I think a lot of times goes very, we take for granted. So what's up with the naming conventions? So why CCOM putter, CCOM X, CCOM Y?
Right.
What's going on?
C, at the time, we had done MFC. A lot of people hate kind of the C this, C that type of thing, but at the time it was our coding convention, and we decided to have that. When we shipped our first version, we didn't have namespace support, and C object seemed, obviously that collides with MFC C object.
Yep.
And so a lot of these terms we just wanted to use something more unique, and CCOM seemed to kind of fit what we were doing. Kind of the other naming convention we have is IMPL,
yes.
which on our interfaces, there's all I dispatch IMPL, I this IMPL, I that IMPL.
And what IMPL means, implement?
Yeah, it means it implements that interface,
interface,
or at least parts of that interface. Yes.
Okay, so it's an abstract interface. Well, which is, of course, they're abstract anyway,
yes.
but you know what I mean.
Mm-hmm.
Okay, so interesting. Well, there's our picture of what a ATL COM object looks like, and it's actually quite cool. And again, we did talk about you use macros quite a bit, you'd expect, and we get a lot of stuff for free without losing control. I still am a little curious about C stack object, because whenever you say you're not ever really going to want to do this, and it's there in case somebody for some reason has to do it. Can we talk about that a little bit more? I know you already talked about it a little bit, but let's talk about it just a little bit more.
Yeah, let's say you're in some function method, right? And you've got an object that you need to, maybe it's main, right? Because in that case, you know it's gonna live for some period of time, right? So you would have to initialize OLE, obviously, or COM. So you do your co-initialize. Then in here, you could have a C stack object of my class. And again, I run out of room. Call it X here, right? And then I may call some other function, G, and pass the IFU, right? So let's say it takes an IFU.
Okay.
So all I have to do is pass address of X, and because IFU is a base class, it'll naturally cast to that. But what it's doing is it's going to pass an IFU here, right? So it's going to use an IFU, and when it returns, and I would have to know the details of what G does, that it's not going to addref the interface and hold on to it. But if I know that, and it's in my own code, which often I will program in a COM style even within my own code, you can do something like this. So when it returns, and now you go out of scope here, C stack object was actually directly instantiated on the stack. In other words, there was no new to create it. And so there's no delete. So when it goes out of scope, it simply gets destructed and the memory goes away because the stack is gone.
Okay.
Right? So one, it's not a huge amount of performance gain. You'd have to do this a lot for it to really matter, like some kind of tight loop or something. So other than tests, I've never actually used it in code. But yeah, it's there because we thought it could be useful.
Excellent.
Tear-off interfaces, which we haven't talked about at all, is another thing.
What are tear-off interfaces?
All right, I'm gonna erase.
You can erase that.
All right. So to understand tear-off interfaces, you kind of have to look at kind of the layout of an object. So if you have, let's say, you're going to implement 10 whatever interfaces, right? Within your object, you're going to have 10 vtable pointers, right? Plus whatever data you need. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So you're going to have a separate vtable pointer here, so, you know, P1, P2, and this will point to, you know, one will be for your main object, which is also your first interface. This one is for your other interface, that type of thing. So there are certain scenarios where you may have way more than 10 interfaces. Again, some of the things like the ActiveX controls.
Yeah.
But there's also cases where, and I think IE, Internet Explorer, was the ones that really pioneered this, because they would have these objects, and each instance they wanted to be very small. So the idea is you could get away with essentially, you know, some little data here. It might be a redirection to some other object. And then you have an interface pointer here, right? And they want to support like 10 interfaces on this model. Well, how do you do it, right? And the idea is that when somebody calls in here and QIs for another interface, what happens is they actually allocate a whole nother object, which has its own vtable pointer and points back to the main object. Okay? So what it means is that if your object can support a lot of interfaces but are hardly ever asked for, you can reduce your memory usage by cutting this way down to only one or however many vtable pointers are actually commonly used. And so what you have is, from a code perspective, you have your my class, and then you have your kind of my class extra stuff. And in this one, you can say that certain interfaces are actually implemented by this guy. And if somebody asks for one of those interfaces, then we do another allocation, create that, and hand out the interface from here. But when you actually run the code, it gets forwarded back to your original class.
Interesting.
So again, it was an optimization thing. We're not going to leave anything on the table. Right?
Cool.
So.
And virtual functions are cool.
Yeah.
I mean, it's definitely one of the things that's clear. I mean, the compile time virtual function calls, right? Again, you guys are all compile time.
Yes.
Templates rock and roll.
Yes, totally.
vtables, virtual functions, right? Now, we have talked about WTL. I don't want to take too much of your time. I mean, I did let people know this would be 30 or 40 minutes or whatever, but this is what happens. So in terms of WTL, as we mentioned on the earlier, it takes ATL and extends it specifically for, I guess in some sense, wrapping more Win32 UI
Right.
components.
It's actually, ATL is about creating components. WTL actually lets you create applications.
Great.
And wraps a lot of the infrastructure you need for that, which includes message loop, frame windows, toolbars, printing, lots of that type of thing.
Great.
But it builds on the core ATL windowing infrastructure, the WinProc thunks, the separation of consumption and implementation of a window.
Yeah. That's great. So again, thanks for taking time. It's great to finally meet you.
Yes,
Come
me
on
too.
Channel 9.
Yep.
And you know, the inventor of STL, excuse me, ATL, there he is. STL,
Yes.
STL, WTL, RTL, what's going on?
Yeah, at least WRL is not a T, right?
Yeah,
So-
exactly, which is actually interesting because it does employ the same level of complexity as far as the implementers are concerned with template metaprogramming. More advanced than what you did in ATL because that was the time. But at the time, you were ahead of the pack in terms of taking advanced C++, turning it into this nicely general purpose library for common programming on Windows. But yeah, WRL is interesting. And for those people out there who don't like C++ CX, there's always WRL, man.
That's right. Or write your own library.
Write your own library. So you can even do it in C or even assembler.
That's right.
Hey man, thank you so much.
Thank you.
Cheers.
Enjoyed it.
Thank you. Me too. Wow, man, templates do make my head hurt. I know a lot of people will say that, but that's what I love about the work that Jim has done.
Yes, yes.
He's abstracted that craziness away.
For me, this was, like kind of nutritive.
Yeah.
I never learned COM, and I haven't been even working with ATL, etc. I
Yeah.
come, I think I have already told. I come from the Java and then .NET world. So
Yes.
all this is pretty new for me.
Well, you studied C in college. So
Yes.
you
I
know.
also work in C, but
Yeah.
was ANSI. So
Fair enough, man. And so, I think it's really nice. I love one of the things I really like about ATL is it affords some of the removal of complexity that
Sure.
MFC does, but it's a lot less heavyweight.
Yes.
It's
Yes.
thinner, leaner, meaner, faster
Absolutely.
for some uses, not all. If you're an MFC person, rock and roll.
Sure.
But for me, I like how fast it is.
Absolutely. And as everything, has like cycles. By the time these technologies were built, in the early 90s,
Yep.
I remember that was the coolest state of the art of these technologies.
Absolutely. And of course, Jim went into the history, and the
Sure.
history is very interesting. There's a reason that that he spent time building this template library, or a bunch of classes, to make our lives easier as Windows developers, specifically. And ActiveX controls, man, they're all over the place, right? So, rock and roll. WTL, also very interesting. I wonder how this stuff is going to evolve. And I really look forward to seeing people's feedback and comments. Now, I did want to call out, because I spend time on Facebook.
Okay.
I'm sure a lot of C++ developers don't really do the social networking thing, but I don't know if that's necessarily true. But I know that Matt, who also gave a good question for the C++ CX interview that we did with Marian, has the C++ enthusiasts Facebook group, which I recommend you go and join. And he created a post about last week about upcoming C++ conferences.
Great.
And of course, very stoked that C++ and Beyond 2012
Sure.
was announced. Rock and roll.
Absolutely.
But there's also now what used to be called BoostCon, which is now called
C++ now.
C++ Now.
And they are calling for papers. We are later going to give you guys the dates if you were interested to submit any proposal, because you should hurry. It's like the deadlines are approaching.
Totally. But I want to say this, man.
Tell me.
All right, you ready for this? Now, I think that Matt missed one. Now, it's not Matt's
Really?
fault. Yeah. It's not
Which
his
one?
fault, though.
No, but
He doesn't know?
I may not be aware. Which
So I wanted to announce a very interesting event that's going to be happening here at Microsoft,
one? Okay.
and stream live, of course, with the great Bjarne Straustrup will keynote it. Herb Sutter will
Wow.
be there. Andre Alexandrescu will be there, and some
The
other
big guy?
people. Those are some names I'm just throwing out early. But I'd like to announce and save the date for GoingNative 2012.
Wow.
February 2nd and 3rd, right here in the Death Star, in the mothership at Microsoft. We want to bring you here, and we want to do some deep C++, and it is a C++ conference, by the way.
Okay. So you are telling me that you already got Bjorn
Yeah,
making the keynote?
making
and
the keynote.
the deep programming language guy, Andrei Alexandrescu, also
Yes.
happening. Oh, I can't believe
And
that.
of course, Herb Sutter. How can we not have Herb Sutter? He's right here.
Absolutely. Yes.
And I think you'll be surprised about some of the other people that are coming and some of the kind of ideas that we have with panels.
So when is this happening?
So February 2nd, February 3rd,
Okay.
mark the date, 2012.
And this is happening in the Microsoft campus?
Microsoft campus in our beautiful Building 33.
Okay.
The best conference room in that building, of course.
Redmond in the Washington State.
Redmond, Washington
US.
State, man.
Great.
It's a very modern, comfortable room. You're going to be taken care of.
Great.
Like I said, we're going to stream it live. We have a very reasonable price.
What is the price?
Now, this is an interesting one. Now, the price is $112 US.
Okay, and why? Why so?
Well, I'd like to turn that question to the audience. Why is it 112? Why is the integer 112? Why is the integer 112? Tell me the answer. If you
Okay.
get it right, who knows what might happen?
So if I guess that, what is going to happen?
Yeah,
to
we'll
it?
see, man.
There any price or?
There probably will be no price if you can get it right.
Okay,
But I
okay,
don't know.
okay.
I'm not going to say that for everybody. I mean, it's going to be a first come, first serve on that.
Okay.
But wanted to keep the price low because, in some sense, if it was just free, my concern was people would sign up, register, eat a spot. Of course, we're being transparent. This is Channel 9.
Yes.
And then not show up and not feel bad about showing up because, well, it's live and
Yes.
I didn't pay for it.
Those who
So
lead
we
user
want
group,
you to come.
sure.
All
Those
right.
who lead user groups in general
Yeah.
know that. You know.
I'd like this to sell out in faster than anything Google's ever done. Come on, C++ developers.
Great.
This is for you. That's why we're doing it.
Cool.
So I wanted to mention that. Save the date. Very exciting. Of course, working closely with you and your team.
Absolutely.
We're going to have some really good
count on
content. And just so people know, I mean, this really is going to look and feel like a C++ conference. And we can let people kind of understand what that might mean.
Absolutely. Well, that's great.
Right
That's
on.
Great.
Right
Excellent.
on.
Well, congratulations for the news.
Yeah.
You have been really working hard. You kept the secret. You know, I had no idea about
I'm
that.
so psyched to get it out. Now, you know, the name.
GoingNative, yes. I was concerned. You know, we started this thing together.
Yes,
I know.
we did.
You know, you were leading like some logistical aspects and you know the image, etc. And I found the name GoingNative, and I never thought about that. You know, why we are known as the GoingNative guys. What is GoingNative in this case?
Well, look, I mean, the thing that I want, it's a great question. I think the first thing that, you know, I want to make perfectly clear about the name, and these are just words, but, you know, it is really all about native programming.
Okay.
And native meaning, you know, you're running close to the machine. You're
Yes.
running on the machine. You're coursing the machine directly. Now, assembler is native code. C is native
Yes,
code.
yes,
There's
yes,
all
yes.
kinds of different.
Go is
Fortran.
native
Come
code.
on. So, in some sense, going native really isn't about leaving somewhere that's not native and coming to somewhere that is. I want that to be perfectly clear.
Okay.
That's not what it's about. It's about, in some sense, you know, focusing on.
Sure.
This is what we're going to do. We're going to go native. We're going to focus on the native aspect of development, the native experience of programming. In this case, C++ is the tool that you use.
It
One
makes
of them.
sense. It makes sense. We are a company who has been pushing C# and the .NET platform for 10 years.
Yeah.
So maybe going native, it's okay, let's refocus on this for a while, you know. That doesn't mean that we are leaving
Totally.
aside. In fact, you know, I'm really excited to see the news and what is happening with the .NET Camp, you know, with the async framework and a lot of things, you know.
Sure. Absolutely.
So I really
But I
like
mean,
that.
also, you think about like going deep. If you're a football fan, for example, American football anyway, you know, you
Absolutely.
think go deep, right? The quarterback's going to go back, wide receivers running down,
Sure.
and you're going to hit them deep.
Okay.
It's the same concept. You're going native. That's what we're doing. That's what the whole point of this.
Cool.
And it's, again, not a replacement, not a blah, blah, blah. But you know what? I'm not in marketing, so I don't have
Sure.
to explain myself. I think it's a cool name, man.
Okay.
So right on, bro.
Excellent.
So we will see you next time.
Absolutely. You can
And
come with me.
We will see you at the conference. There may be some surprises. All right,
February
man.
2nd and 3rd.
February 2nd and 3rd. Save the
2012.
date.
Okay.
No.
We are not destroying anymore. Some guy said, you know, it's
Yeah,
like
we're not.
we need to delete the program. No, we are using smart pointers now. You know,
You got
everything
it.
It's gone.
You got it.
Okay.